Hey folks, welcome back to another video. Today we're looking at question 366, find leaves of a binary tree. The way we'll be approaching this problem is by using DFS. And by doing DFS, we'll be trying to get the height of the tree. And then where the height of the tree would mean that the lowest node would get like a 0 value. And that's how we'll be arranging the problem. And then so the root would get like the root of the tree node would get the highest value. So that way we can use the height of the tree also as an index where we want to add the element. So let's get started. The first thing that we want to do is we want to create a list of lists that we will be returning. Let's call it rest for shuffle result. And right, awesome. And since it's a tree problem, and if you have practiced tree problems before, usually most of them are recursive. We'll do the same here. We just call like a helper method recursively on root. In the end, we would just return the resulting list. Awesome. And the helper method, what that would look like, it would actually be calculating the height of every single node. So it would be just the signature of the method would look like int helper and then tree node a root. And so we need to tackle the first base case, right? So if root is equal to null, you just want to return -1, right? And then if not, you want to get the current height of the particular tree, right? So how do you do that? You do that by incrementing the current level plus getting the height of everything that you see below. So it would be helper of root dot left and root helper of root dot right. But the thing is, we need to get the maximum of both of these values. And why do we need to do that? It's because all of the roots need to be added at the same level. So here, if you see in the example, even though they're not really at the same level, if you get the max height for that particular iteration, you know where to add them. So that's the reason why we take the mat.max. And once we have that, we'll check if for the given height, there is a value or not. So for int height, the current height, if it is equal to the size of the tree that we're looking at right now, sorry, the size of the list, that means we haven't really added anything yet. So what exactly does that mean? So let's say we're actually at the roots, right? So when I see the roots, I mean like the last elements of 5 right here. When you actually return that, you would get a 0. So when you're asking for the current height, you pass in 1 and then you try to keep calling it incrementally, but it hits when it's null, it would actually return -1, right? So your value current height here would be 0. So it would be 1 plus -1 would be equal to 0. And then when these are equal, right? So the current size is actually of the resulting list is actually equal to 0, and the current height is also equal to 0. That means we haven't really added anything yet. So you would create a new list. So you would say new, so res.add new array list. And once you've added that, you just pull that particular list at that given index. So res.get current height dot add root dot value, right? And then in the end, you just return the current height. So that's honestly the entire solution. So you just keep calling this method recursively to get the height of a given for a given particular tree node, and then you add that in the right index of the given array list. Awesome. So let's compile this and see if it looks okay. The first test case is okay. Everything else is okay as well. Awesome. So let's talk about this based on the time complexity. The time complexity of the entire solution is of n because you have to iterate through all of the nodes. And the space complexity is of n as well, since we are storing all of the nodes that are given to us in the tree. in the list that we have to pass back. Awesome. So that's a solution for this problem. If you have any questions, please let me know in the comments below. Please don't forget to subscribe to the channel and like the video. I would really appreciate that. It keeps motivating me to make more videos. Thanks so much. And I'll see you on the next video. Peace.